my goodness, we're already into autumn. It's fall, the days are cooling off here in the desert. Consensual science validates discoveries. Until that's done, what I might call a discovery is a discovery for myself. Without consensuality, it's not science, because science is communicative. If I were to give a name to what I've discovered for myself, it would have to be called a philosophy. Of course, it's much more than that, and that's what we're going to explore today. The so-called black hole, a magnificent object. It was actually discovered in a star system. Only one of the stars could be seen. The computation of an orbital pattern of a star in a binary system, ordinarily both stars are visible. It's an elliptical relationship in a two-body system. They actually revolve around each other. So they have a more or less steady gravitational interaction. And so they don't crash into each other, they just circle each other. It's really quite amazing. Sirius A and B are another rather famous example of a binary star system. So when you find a binary star system but you can't see the other component, it doesn't mean it's not there. It means it's not luminous, and this was the extrapolation which led to black hole theory, because the density of the other object was much too great to be computable as an ordinary gravitational object. It was a supergravitational object, even though it was non-luminous. And this was eventually labeled X1, so it's called Cygnus X1. Well, in the case of the Cygnus black star, it was not supermassive, it was just extra massive. Then later, it was discovered that the center of a typical galaxy have a center which can be computed as a supermassive gravitational center. And this was the beginning. And the reason it's called a hole we're all familiar with now, since you're not allowed to not know it. No matter who says it, you have to be sure it's correct. Science does not recognize thrones, robes, or titles. We only recognize logic. Nothing compares with a supermassive black hole. Normally, a collapsed object, such as a neutron star, which is hyperdense, you could put it, but it doesn't form a singularity. It doesn't form an inversion. Now, of course, this is a mathematical extrapolation. So hyperdensity is contractual. A neutron star has enough mass that if it were not hyperdense, it would be much larger, but with the same gravitational aspect. These thresholds now have very fancy names, and many of you, I'm sure, are familiar with these. There's an event horizon and a singularity, and these are not conceived to be the same thing. The Schwarzschild limit is part of this whole systematic approach. Now, what's remarkable, and the subject of the greatest controversy, is what happens when the gravitational strength, that it inverts. That conclusion appears to be inescapable according to the astrophysicists. And this is an extension, or a hyperextension, of the concept of gravity. So what I would like to do today is to give you some perspective on this problem. And it really is a problem, because there's something disturbing or fishy. The mathematics, nobody argues with the mathematics. Well, you could be wrong with your mathematics, and that is being questioned as well. And so various approaches are still being taken to analyzing this fantastic object. It's so much mass contracted to such a small core that it turns either inside out or leads to a complete contradiction in logic. And therefore, it's considered now to turn inside out, which does not make a great deal of conceptual or perceptual sense to a human being, because according to Newton's simple law of conservation, it can't just keep disappearing. This is a force line, a spherical force line that pulls in so strongly that it turns inside out into another space. This would be anti-space if there is such a thing. Nobody has been able to figure this out, and so we're left with the original data, and everything else is just mathematical scaffolding. The supermassive black hole typically exists at the center, it is believed now, of any galaxy of sufficient size has a supermassive black hole. Our own galaxy, called from the inside anyway, the Milky Way, from the outside it's called Via Lactea. So it does have two names, but Via Lactea is Latin for Milky Way, so they mean the same thing. But it is interesting now to consider that a galaxy does not only have an outside, wherever it ends, which is also difficult. Nobody is certain of any of this. Astrophysics has never developed a consistent theory of the origin of cosmological objects, such as galaxies, very large-scale objects. So all of that is still being explored, but what we're looking at today is the center of a galaxy, the gravitational center of a galaxy. We could use our galaxy as an example, but it's a little difficult to see through the stars and dust and gas. This has been done, though. Our own supermassive black hole does not look like a supermassive black hole. These artist conceptions should be illegal. Time-lapse photography was taken of the stars that are circling the center of our galaxy. We know exactly where it is. We can look right at it, and of course we don't see anything, but here's the problem. The stars are not distorted. And when the star goes behind the black hole, they don't disappear. So the light is not blocked. And what that shows is there's actually nothing there. And there's nothing there that even bends light. There's no gravitational lensing. There's no distortion. There's nothing of what you see in the artist's conceptions of what would be around the black hole that would be visible. And there's no ring. There's no nothing. So that just destroys the theory as it exists. And so you would expect, now that we've seen with our own eyes a supermassive black hole, our very own, we've weighed it. We know how much it weighs. And it does form a singularity according to the mathematical extrapolation. The problem is it doesn't exist. It's a total projection of the human mind. Is absolutely incorrect. And that leaves a new problem. So you would expect that the astrophysicists would be throwing up their hands and perhaps tearing their hair, going back to their blackboards and talking about this day and night. What the hell did we do wrong? Do you think that happened? It didn't happen at all. The same thing happened that always happens with a model in modern science. And I can give 3 other examples of a model that rose to ascendancy. It was the first pass guess at either the origin of the universe or the supermassive black hole. This even goes to the particle physicists. They developed a model, and now they will never abandon it. No matter what new evidence appears, they'll never abandon their insane notion. And the origin of the universe, the same thing. Children are taught this. Massively criminal to do that. That destroys the minds of the youth when you force them to accept a false model. And the ultimate example of that is biological evolution, Darwinism, natural selection, which all modern accredited scientists are forced to accept. I don't know if a poll has been taken, but I suspect there aren't very many scientists who would even dare question that psychotic theory of human origin. And it's been disproved, completely disproved. And yet nobody cares. And Wikipedia offers a reason for this. I disagree with their logic, but I understand why they're forced to put it this way. That once a model gains ascendancy and just defeats all of its rivals and now becomes the dominant model, it cannot be dethroned. it can no longer be dethroned because science has warped itself. It has no feedback system. And so it can't correct itself. And you just keep grinding out new mathematicians, just keep grinding out new physicists who are forced to catch up with false models, and they're not allowed to question those models. Well, that's not science. I'm sorry, but it's just not science. And now it shows. So what we're going to do today is develop a new model. Only this one won't be based on false mathematics. It is a mathematical problem. And everyone knows that now, but nobody is willing to challenge it for various reasons, the main one being that people are just too stupid. They don't know how to get themselves out of their trap in mathematics. They can't do it. So rather than admit that they've been defeated and can't figure it out and never will, you know what happened instead. It's just pretty psychotic. So let's see if we can get some rationale, some rational logic back into our analysis of the supermassive black hole. What is it really? What is it? All right, it's much easier for us to look outside of our galaxy in a direction other than toward the center. It's very difficult to do that kind of photography. It has been done, though. But we have many more objects that we can study, really billions of them, called galaxies, which fall into two main groups according to Edwin Powell Hubble's tuning fork model, which has stood the test of time. There are only two main kinds of galaxies. There are spherical galaxies, which for historical reasons are called elliptical. In one sense, that's more correct, but they're spherical. They're just not perfectly spherical. But it's a major difference in geometry when you go to the spiral, and then you get those beautiful spiral arms. Those spiral galaxies, among the two groups of galaxies, are about 45% of the galaxies in the universe are spirals, and 55% are spherical, which I'll call elliptical because that is the conventional term. So the elliptical galaxies are generally more massive, and they're also composed of a different statistical type of, statistically they're composed more of red stars, which is why elliptical galaxies are not visually attractive to the same proportion as spiral galaxies are. To me, the typical spiral galaxy is the most beautiful object in the universe. That's just me. I'm sorry, but I love. That's why I got into science. And I've told this story, but I'll tell it quickly again. That when I had never seen galaxies, I was in my 40s. And an astronomer team, man and wife team, produced a slide lecture that lasted somewhat over an hour, I think. And there was quite an audience. There wasn't just a few people. There were a lot of people interested in this. And the slide presentation was top-notch. Started out with the solar system and then galaxies. And I had seen some photos of galaxies, so I was really impressed with those galaxies. But then a turning point was reached. I saw something that I had never seen before. It just wasn't exposed to me in my educational system or in my daily life. I just didn't know. The galaxies all occur in groups. They occur in spherical groups, which were called galaxy clusters because the naming system for science is a little wishy-washy. But a galaxy cluster is good enough. That's what it is. It's a spherical cluster of galaxies, about 100 to 1,000. In a typical galaxy cluster. And these actually fill the universe, you could say statistically, completely. To the same proportion that galaxies fill the universe, well, all galaxies are in clusters. So you could say that the building block of the universe is the galaxy cluster. That object is so important that I felt constrained to give it a new name, and I developed a new naming system for the what I call cosmic units, the luminous objects that statistically fill the universe. Of course, begins with a star, and then stars form galaxies. Galaxies form clusters. Those clusters form another structure. So you could think of these as beads, not super, but clusters of galaxies are like beads that fill the universe, but not randomly. They're strung together in polyhedral patterns, where at nexal points there's a lot of these clusters, and then there are strands that go out and then meet other galaxy clusters, so they're connected on strands. This is called the cosmic web. And without extrapolating further in that direction, although I have done so in several presentation series, it's ultimately fascinating, because it gives you a true picture of the universe instead of some mathematical, fanciful, rather psychotic impression. Because you can see it. Okay, so the luminous objects are stars, and then groups of stars, then supergroups of stars, and then stars that make this pattern inside of galaxies, inside of clusters of galaxies, which then form what used to be called superclusters, but then it was found out that those superclusters are all interconnected. Well, it's an amazing story. So we now come back to our typical galaxy, which is either elliptical or spiral. Ours is a spiral. Our nearest neighbor, Andromeda, is a spiral. There's a third spiral galaxy in what's called our local group, which is considered to be a gravitationally related system of 3 spiral galaxies, plus a whole host of dwarf galaxies. And Fritz Zwicky did a magnificent amount of research in exploring smaller and smaller galaxies. And there's a whole classificational system of what would probably best be called satellitic galaxies. They're really the satellitic galaxies. There's hundreds of these. Our own galaxy has many of these smaller galaxies going around it. And there is some relationship, it is thought, between those and globular clusters, which are really an interesting object. So there's a lot to know in astrophysics that is just, you can see it, so it's worth knowing. Well, that was the original intention of my video series. Although then I made a discovery in geometry that changed my syllabus. I feel that this geometry is the most important thing I have to offer to science. So we're going to use that new geometry, and you'll see how it works in just a moment. But we need to think about the elliptical galaxies now, and the supermassive black hole that exists at the center of a typical elliptical galaxy, because these supermassive black holes can become active. That is, we can see that there's a relationship between various centers of galaxies, such that the center of one galaxy might be luminous. But most galaxies have a dark center called a supermassive black hole because it's non-luminous. So, not all galaxies have that. Some galaxies have an extremely bright center, and that is ordinarily called a quasar. Although you will often hear the term active galactic nucleus, or AGN phenomenon. These are objects that are superluminous, that occupy the same position that a supermassive black hole otherwise would occupy. The center of gravity in a whole class of galaxies, and there's millions of these, they're called quasars. And they are all galaxies. That's been proved. But they're not ordinary galaxies because they're not as extensive, which suggests that they're either younger or older than ordinary galaxies. And I'll show you which one that is in a moment. So now we have a more general perspective on where supermassive black holes occur. That doesn't mean that we've discovered where all supermassive black holes are, because of course they're invisible, but they're detectable according to their gravitational influence. So there's really nothing that I know of to say there could or could not be supermassive black holes. They're just out there, and nobody knows anything about them because you can't see them. We're not sure. Because science, of course, is progressive. We can't know everything yet about such a vast region of space, which is a lot. So, but we can see a very close elliptical. The closest ellipticals to us are they're not far away. In other words, we can see them very well with telescopy. And these galaxies have names, these elliptical galaxies. And I don't want to introduce needless terminology, because what we're trying to do is get to the geometry and the mathematics. But first of all, we have to actually see it. Well, it's really hard to do. So we know of the presence of these objects because of their gravitational influence. And that gives us all the information we think we need. Makes sense to me, so we're going to proceed on the assumption that we have correctly analyzed these objects to be gravitational objects. That much I don't think can be denied. Whatever else you say, you've got to say they sure exhibit a strong gravitational influence. So the nearest one to us is a different sort of supermassive black hole. It's definitely supermassive. It's very close to us, so we can look at it, and we can analyze the galaxy and see that is correlate its gravitational profile with the gravitational center. The problem with this object is that it's luminous. That is, it's not luminous at its center, but it shoots out bipolar jets of matter. It's actually bipolar jets of plasma. And even that is not perfectly understood. It's bipolar jets of something. And they're definitely coming out. And they shoot in two opposite directions. If you saw one of the later Star Wars adventures, you know that in the first adventure you had lightsabers. It just goes whoosh. Now you have a lightsaber. But then, I think one of the Sith, or whatever they're called, Sith, this guy had a double. You'd hold it and just woof in two directions. Well, think of that woof as this object that we've seen. It's shooting out two jets in opposite directions that go kiloparsecs. In other words, very far-reaching jets of matter, luminous matter. And so we can see them. And there have been time-lapse photography sequences taken of these jets. So we can actually measure the velocity of the whatever. We'll just call it plasma for now. That's probably the best guess. But it's plasma. It's going out at so fast, it's a very high fraction of the speed of light. And because of a certain form of relativistic illusion, though one of those jets measures at superluminal speed, which of course is a violation of the speed limit of the universe according to Albert. So that would seem improbable. Well, that actually can be explained. And there's a term for that with analogies that are somewhat, I would say, convincing. So it's not going faster than light, although the spectrographic reading says it's going faster than light. but it's not. That's actually an illusion. So that can be computed back to its actual velocity, which is still a very high fraction of the speed of light. So this is very strange, very strange. But it is associated with a supermassive black hole, which is supposed to swallow all light. So why does it have a double lightsaber? Shouldn't that light be unable to escape? So a model was constructed to explain that. And it's perfectly accepted, but I need to present it to you, and I don't expect you to accept it because it does not make sense. It's what's called a kludge or kludge. It's when you take a piece of bubble gum to fix your model, but it's just a makeshift to hold it together so you can look at it and study it more. But eventually you need to come back and remove the bubble gum. Well, nobody wants to do that. They're much more interested in the bubble gum. So the artist's conceptions come to fill in the missing piece of how is this double lightsaber coming out of a supermassive object. That literally is a contradiction in logic, and every form of physics is just purely violated by that. So what in the world is happening? The model that was constructed to explain this is the typical kludge of an astrophysicist steeped in cosmological modeling. That, it has to be accretion of some kind. Because we know already that the supermassive black hole cannot be emitting this double lightsaber. Well, we think we know that, but it's doing it, so you have to explain it. Well, what's said is it's not coming from the black hole. Where it's coming from is spinning material called an accretion disk. Well, an accretion disk still doesn't explain why it would shoot two superluminal jets. Just to put it in the vernacular. So the way that was adjusted was, well, there's a spinning component. It could be the supermassive black hole itself that's spinning, but whatever is generating the angular momentum in this region causes matter that is coming toward the black hole to go into a rotational system of very high velocity, which at the poles comes out. So it's spinning, and it's a double vortex that then generates the lightsaber. Now that actually does not make sense, but it's the only guess that anybody has. And so it's accepted against all logic. Now, if you accept it or not, makes no difference. That's up to you. If you want to accept something that makes no sense because there's no other explanation, you can still call yourself a scientist, and you're perfectly welcome in the astrophysics community. So if you want to join them and study it too, all you have to do is go to school for 16 years, which will cost you $100,000 to $200,000 to catch up on the mathematics that generates this error and see if you can fix it. I'm going to show you the shortcut. And that's what actual science does, is it produces the correct solution, which I have, and now I'm going to share. So the way we're going to approach this most interesting, most fascinating, unbelievably tantalizing problem, we're looking for the solution. What is a black hole? What is it? All right. It is now considered that the singularity, where space and time disappear and physics breaks down, this is the standard model of the black hole. I'm not making any of this up. I'm just telling you what is said. Oh, and God help me if I get anything just slightly wrong. That is not possible because you're dealing with a chimera. The model cannot be correct. We already know that. It's just nobody knows how to solve it and get the right answer. We begin by exploring the inversion of physics, the inversion of space-time, where space and time literally disappear. This is against the principles of every form of physics, mechanics, and dynamics. It literally cannot happen, but according to the mathematics, it is happening. So since mathematics is God for these psychotic maniacs, and they are. Oh, you have to keep calling them that until they get it through their heads. They won't. But that won't stop me from calling a spade, okay? Which is a shovel, okay? Not... It's like a coon's age, you know, you can get in trouble for saying shit like that. I'm innocent, but nobody's innocent if they use the words wrong, right? Bullshit. All right, so what actually is happening? Well, we're going to assume now, this is called a reductio ad absurdum, or proof by contradiction, is indeed space, physics, time, logic, just anything real, just being sucked into something so unreal that it just disappears from the rational universe. That is the current definition of the singularity. So why would anybody say such a thing? It's because the gravitational attraction normally stops. In other words, there's no black hole at the center of the Earth. We don't think. And there's no black hole at the center of the sun, because there's not. But what is there? There's just a gravitational center. Well, already that makes no sense. Why not? Because gravity is pulling space toward itself. It's bending space. Albert proved that. That doesn't necessarily mean that space is a substance that can be bent. This is the ancient, well, now virtually ancient, ether problem, which has never gone away. The conception of an elastic medium, which we would then equate with space. Well, that's quite an interesting proposition, that space could bend. Space bends. You have to understand something about that it doesn't mean that space is a substance that bends. What it means is that what it looks to us to be is the bending of space, and that's how we can interpret it to get some kind of visual model of what is gravity. So what is gravity? Do you know? If you do, you're the first person to ever know. Nobody knows what gravity is. We have a constant, and it's listed among the fundamental constants of nature, G, capital G, which has a value. What's it a value of? Well, there have to be units, otherwise you can't interpret the number. It is a number. It's a linear number. And if you've been tuning into my recent or any of my lectures over the past 3 years, you know that we're talking about a force, okay? Now, many physicists, about half of them, assert quite strongly that gravity is not a force. And you may have heard, even Sabine Hassenfelder has given a whole presentation where she just screams, virtually by repetition, form of propaganda which a scientist really should not indulge in, but she feels so strongly about this. She said, I don't know how many times in her, it was about a 20-minute or 30-minute presentation, that gravity is not a force. Well, you can say that. Why? It's because it's a force that has no motion associated with it. Although you may realize there's a loophole there. The actual, I shouldn't say actual, there are two ways of viewing gravity, where either it is a force or it's not a force. It's about evenly divided, and it's amazing to me that nobody's ever decided this. It's an open question whether gravity is a force or not. Well, when it comes to the supermassive black hole, you better know what you're talking about. So, what do we actually know about gravity? Well, we do know that it exerts what is called a centripetal force. It is a force. Centripetal means that the force is pulling something in. The way we see that is that the sun is pulling the planets in. Newton proved that. Well, he's one of them. I'm going to put this on pause because I'm getting a phone call. It's probably a... Never mind, I'll be right back. Boy, it's a good thing I learned how to use pause. I picked up the crank call and they just hung up immediately. It's like getting junk mail. Sorry about that. Anyhow, to decide whether or not gravity is a force is really arguing about words. Gravity is what it is, but it is significant because every other force is conceived to be a linear force. That if something is just sitting there and an object comes along with velocity and strikes that object, it's striking the object with force. That's linear force. That's a vector. Now in gravity, you have a spherical vector, which is a contradiction in terms, so we need a new term other than vector, which is strictly a linear term. This is a spherical force. And we're going to use the word force despite with what Dr. Hossenfelder says. We're going to choose the other side of things, that it is a force. And in fact, it is a force. But it is conjugal to another force. This is how we actually discovered gravity. Kepler was the first, then Newton improved on it, and then Bošković got the actual solution, which was instantly forgotten. And now it's being recovered. But that's the history of gravity, until the discovery of the inversion of gravity, which is highly controversial for obvious reasons. But it's so important because it describes the whole universe. I mean, the whole universe in the sense that it's filled with black holes. Well, what are they? You would have to say, according to this modeling approach, that they're force centers. Well, that's very interesting. Now, I want to draw a loose analogy so we'll have a proper framework of approach. And here's the analogy I would like to draw. Where do we find the source of light in the universe? You may or may not know, so let me just give you the answer. If you say star, you're partially correct. That is correct, but you're not entirely correct. There's exactly and only one other source of light in cosmic space, that is macrospace. We're not talking about the electronic level now, or the protonic level. That's actually a bit different, but we're getting there. We're talking about macroscale light sources. There are only two. A star explains all light in the universe except for one object, the quasar, which is a galactic scale light source. It's the nucleus of a galaxy. So galaxies have one of two kinds of nucleus. It's either dark or it's ultraluminous. And these are the two extremes. One is always taught to us as being something that swallows light. It doesn't let light out, but it does something much stranger. It pulls light in and then forces it to disappear into a wormhole. And that's what the singularity is now called. Brian Greene has given presentations on this, whereas he has invited Dr. Leonard Susskind, who is a mathematical genius, a mathematical expert, along with a couple of other guests. You can look that up. It's a Brian Greene presentation where they talk about wormhole the wormhole hypothesis. This is to give some kind of tangible or perceptual reasoning to where is light being sucked to? Where does it go? The current model is that everything goes to the singularity and then disappears into anti-space. And that anti-space is now conjectured to be connected, invisibly connected, so that it is now conceivable to jump through a black hole and come out in another black hole. This has been extrapolated so far, rather psychotically, I must say, that there is also a perception in extrapolation space that there's such a thing as a white hole. They're mathematically inconsistent theories. Do you know the mathematical definition of a singularity? What I like to do is to make things simple for a general public, including myself, such that you can actually see what these things must be in a way the physicists simply cannot. They've blinded themselves to reality. They've decided that they're well within their rights to violate physics. And that's what they're doing. To support their violations of physics, they use mathematical tricks. And this trick involves the old standby for any form of psychosis, zero. The singularity is a zero. So that's where everything goes. That's the mathematics proves that. That what is disappearing where is the question. Well, everything that's real, that we call real, such as matter and light, they are sucked down into a drain and disappear into another universe. It's that simple. So all you have to do is imagine another universe. This form of expression is now so prevalent that it's unconscious. That top-notch physicists, including Nobel Prize laureates, the very creme de la creme, they routinely refer to other universes. Either one other universe that's called a parallel universe, or many other universes called the multiverse theory, and there are all kinds of schools of thought, and they all argue with each other, of course, because it's fun for these guys. Well, it's not fun for a man who's looking for truth. It's the opposite of fun. It's a nightmare. So I want to make sure that you have a rational perception of the supermassive black hole. In order to understand what's happening, you do have to begin with the actual physics, which is, it is a force that's pulling in. Well, are there any other examples of that in the universe? Yes. Everything that's made of matter forms a gravitational field. You might ask why. We're not going to ask that at this moment. But are there any other examples? Oh, yes. Because what causes gravity? We know now. Everybody knows. But because what we know about gravity conflicts with the model, then instead of sticking with what we do know, mathematicians just dive right off into psychoto land because their mathematics gives them the right, they think. Well, there is one other source of gravity in the universe, and it's at the quantum level. It's called a proton. And the proton is actually a black hole. For the same reason that every gravitational object is a black hole. Because it has a center of gravity. Now, what's thought is that in anything less than supermassive size, there is no singularity. But what is there? Nobody's ever said what is at the center. But if you think about it for just a moment, you'll realize that the paradox of supergravity, that is, you could say hypergravity or inversion of gravity, that's actually the conservation of force. Because for every action, there has to be an equal and opposite reaction. That produces the wormhole, and that produces the other universe. So it is thought, because that's the only thing you can say. It goes into Lulu land where physics cannot reach. They all admit that. Dr. Leonard Susskind really kind of hangs his head and shakes his head when he has to report this, because he's aware of the contradiction. But then what do? These men are under enormous pressure to provide answers to fuel an industry which generates trillions of dollars from suckers who just want to know about shit from the experts. Well, these experts are not going to turn down that money. They want that money. So some of them hang their heads and some of them just are happy-go-lucky. You know, you get these guys like Michio Kaku who could sell you dog shit. He's so eloquent. So what we want to do is get a more reasonable grasp on gravity. Do we actually understand what gravity is? Well, not at all. We actually don't. Although we do have Newtonian mechanics and now we have Einsteinian spacetime, which are reasonable models. But they're exactly that. They're reasonable models to explain the orbits of planets around a star and to explain gravity as we encounter it at galactic scale and beyond. We use the same Newtonian mechanics. And Einstein did not change that. He didn't challenge Newtonian mechanics at all. What he did was to create a larger space. He jumped from 3D to 4D. Well, that's quite a jump. Because 4D space is much, much larger. The problem with 4D space is that you can't see it. But you can see a subspace of it. You can see 3D space. That's what we call it. That is the space that we see. And it's also the space that we think is real. That is, we compute that space using distance. Now, what Newton did was he assigned two linear components to a gravitational system. They're linear. So that on a calculus derivative, where the two lines meet at a tangent, these are two force lines. The planet is going on this straight line, but it's being pulled by a perpendicular force on a straight line at the tangency. That's how he did it, and that's why he invented calculus, exactly for that reason. It's to explain the curvature with two numbers. That can be done. We know about linear velocity, that if you set a planet in motion through space, it goes on a straight line. I think we all accept that. Well, here's the star, and here comes the planet. If the star has no gravity, then the planet just keeps going on a straight line right past the star. It reaches a tangency, the closest approach, with no effect, and it just keeps going. But the star does have gravity, so it is exerting a force. And that's how Newton interpreted that force line. But you can see it's just a infinitesimal of the actual force, which is spherical. So you could think of a single line of force. You can draw it right from the center of gravity outward. Now the planet will just get right to it. It's reaching its closest approach. And of course, it has an approach, so it's already feeling gravity. But when we get to what he said is you can think of it as having its linear velocity. So the planet has a linear velocity, but it's being pulled from a center of gravity, which throws it off course in that direction. Well, you can compute that as a rate. It's a rate of change. That is the result of a calculus computation, is you get a two-component number. It's very rarely expressed that way, but that is what the calculus does. It gets a relationship between two linear components called a rate. So it's the proportion of one linear quantity to another linear quantity which is at right angle. So now you can use the Pythagorean theorem, which I will continue to call it by that stupid name. It's the right angle law. This is the linear law. The law of linear algebra is the right angle law. Otherwise, linear algebra would have no use in space. It would have no use in 2D or 3D or 4D without the right angle law, because it relates the two orthogonal lines. In order to relate them, you need calculus. Calculus gives you a two-component number from two single-component numbers. And you can treat the two-component number, since it's a fraction, you can reduce it to a linear number. From a two-component fractional number to a single-component linear number. And that's the value of the calculus. It gives you that rate as a linear number. But it's not a linear number. We just pretend it's a linear number. It's not a linear number. Because it's describing the curve. It's the rate of change between two quantities that are perpendicular. That's called conjugation. So, but conjugation is not used. Instead, what is used is the calculus. And that's summing up a lot of information. I hope I didn't bewilder you in any way with my summarization, but this has to be brief. We're already over an hour. So, when you look at the proton, you discover that it exerts centripetal force. So the source of gravity is the proton. Now that is well known. It's just not advertised that way. Because it highlights the hole in our perception of gravity. Because the proton obviously is the source of gravity. It's the only known source of centripetal force. So the weight of the sun is the weight of its protons. The weight of the Earth is the weight of its protons. And the protons are all in one spherical object. So they work together. That's called the integral of protonic centripetal force. That is the definition of gravity. Now that is known, but you don't hear it said that way. The gravity comes from protons. So the proton is the only source of gravity known in the universe. Nothing else exerts gravity except the proton. Which means that it's the unique space particle, because it makes a position in space. How do we know that? Because of its influence on the space around it. So we call it a particle because it remains stable. A proton has a lifespan greater than the projected lifespan of the universe, according to current mathematical modeling, which should again tell you something about the mathematical modeling. But I'm sorry about the noise in the background. I do live in a city. Those are the emergency vehicles heading to the source of a mathematical crisis. See what can be saved of rational logic. So the proton is a gravitational center. Well then, why doesn't it just suck all the electrons into it like a black hole? Well, the reason that the proton does not suck all of the electrons into it is because the proton is not just exerting a centripetal force. That actually would violate the law of the universe. A proton should not exist if it's just a gravitational object, because it's the same as a supermassive black hole. It is a singularity. It's a hole in space. It's a hole in space if it's just sucking in and doing nothing else. The secret that unlocks everything was discovered by Ruger Bošković right after Newton and Leibniz died, and Bošković found a solution that is so elegant and so explanatory that I am simply going to tell it to you. The proton exerts two forces that are balanced. It can be proved, and it has been proved, although this is not widely known, that the proton not only exerts a centripetal force field, but it exerts a dual force field that alternates. So that instead of bending space, what the proton is doing is it's conjugating what you could call space-time, but it's not time. It's conjugating space energy. It's conjugating motion with space. And the way the proton does that is by exerting an influence both on space and on energy. The electron is energy. So instead of crashing into the proton, which is the direct implication of Coulomb polaric force, obviously electrodynamics is inadequate and incomplete. Because what Maxwell discovered was the orthogonal relationship between space and energy. That is what he discovered, but he didn't know that that's what he discovered, and nobody's realized it until very recently. That orthogonality is the orthogonality of motion with space. Because motion simply is not space, and space simply is not motion. So space does not bend, and energy does not disappear. And the proof of that is the construction of the atom. When an electron is supposedly drawn towards the proton by Coulomb polaric force, because they have opposite charges, that means the electron will accelerate into the proton, and then you would have to guess that they would annihilate. Well, that can't happen because of the conservancy laws of the universe. So what happens instead proves that physics is consistent. Because the electron accelerates towards the proton and then keeps accelerating but at a right angle. So here's the proton, and the electron comes toward it, and it accelerates and disappears into perpendicular space. That's called a orbital. That's called a shell orbital. And it's perpendicular to the force line. So if you haven't seen the prior lecture, you should review that now. Because that force line is spherical, but there are two forces involved. And there's a force transition range at 1 femtometer, exactly 1 femtometer. And leave a comment if you'd like to challenge that. I will defeat you. The force conversion radius, which is a spherical shell generated by a centrifugal force field that then transitions to centripetal. The electron is coming in because of the centripetal attraction. But when it reaches the centrifugal transition, it goes to a spherical right angle, and that explains the dynamic force balance of the atom and of the universe. So now we can turn to the supermassive black hole, because now we know what it is. It's a superproton. And it does the same thing. It exerts two force fields because it's a protonic core. So it's exerting two force fields. And it has a range, a limit, equivalent to 1 femtometer, although at a much grander scale. Instead of 1 femtometer, it would be 1 something. But it's a 1. That's the 1 of the universe, is a spheric shell around a proton or around a supermassive black hole. So what's actually happening is you have what appears to be an object. And in the next lecture, I'll show you that there's a life cycle to a supermassive black hole where at one phase it is an object made of protons, but at another phase it's not. It's actually a hole in space. So it could be massive or it could be anti-massive. And that would have to do with anti-gravity. But that'll be in the next lecture. For now, we need to wrap this up because we're approaching 100 minutes, which is a lot for any human. I hope you enjoyed this so far, but we need to wrap this up. And of course, this will be incomplete because this is one of the greatest breakthroughs in the history of astrophysics. I made this discovery single-handed, or single-handedly. I did it myself. I discovered this. Because of Ruđer Josif Bošković's work and my discoveries in spherical geometry, they're perfectly correlated and they explain physics at all levels, answering all paradoxes. The supermassive black hole is simply a proton at very large scale, such that it exerts a centrifugal force field so that it remains an object. It's an object just like a proton with a force field around it that keeps it an object, and that's its force field. Well, that force field transitions at a certain radius to centripetal force. So that is what might be called the event horizon. And this is a misinterpretation of what a true event is. The misinterpretation of the event horizon is that it is the inversion of time. Well, that's ridiculous, so that's incorrect. For obvious reasons, that's not the right answer. It's not an inversion of time. Time does not invert. Time is a derivative concept of force. Only it's energic force. It's the force that is compared with gravity. It's electronic force. It's energy. Energy is angular momentum. That's what the electron is. It's angular momentum. The proton is the opposite of that, but they're conjugally opposite, and the Bohr atom proves that. So now we have the orthogonality between space, based on a spatial force field, and the inversion of that force field, which affects, instead of affecting space, it affects energy. Now, in the object that is called the SMBH, or supermassive black hole, this inversion appears to occur at two ranges. One is the edge of the supermassive black hole, called the event horizon. And the other edge is the center, which is not ordinarily conceived as an edge. Oh, yes, it is. It's the edge of the universe, where the universe disappears into a singularity. Well, all that is the center of gravity, but it doesn't invert. That's an illusion. What is actually happening is that the interior of the object has an unusual centripetal force range, such that all we see is centripetal, but we don't see the centrifugal. But the centrifugal force has to be there to hold the object as an object. So it does have a force field. It has a dual force field, just as the proton does. And that's as far as we can go right now. As a scientist, you have a certain responsibility to truth. You're not just an entertainer. You're not just a monkey. And you're not just a money machine to fuel the cemetery. You need to collaborate with other scientists who are on the right path. I don't know if you can justify your existence when you call yourself a scientist. Keep looking up. This is Anagalactic with the Secrets of the Universe. We'll be back with a second presentation on the supermassive black hole, so you'll see it perfectly. We'll be right back.